Hello there, my name is Michelle King. I'm a principal planner with the City of Sunnyvale and the project manager for the Moffett Park specific plan. The City of Sunnyvale is in the process of updating the Moffett Park specific plan. This exciting initiative will result in a new long-range plan for Moffett Park. As part of the outreach effort for the specific plan, we are pleased to introduce a new video series. In this series, our expert consultants will share key findings from their research on existing conditions in Moffett Park. Topics covered by the videos include mobility, land use, ecology, open space, market conditions, and climate change. Each video is accompanied by a mini survey for you to share your thoughts about the content presented in the videos. Community engagement related to the specific plan is continuing. More interactive online workshops are planned for later in the summer and early fall. For more information about the specific plan and opportunities to get involved, visit the project website at moffettparksp.com. Thank you.
Hello, my name is Micaela Basso. I work at the San Francisco Estuary Institute. We are a science nonprofit and part of the consultant team for the Moffett Park specific plan amendment. We're focusing specifically on urban ecology and climate resilience. So today I want to talk about urban ecology, or the integration of natural features in the urban landscape, and how investments in these features can be part of a multi-benefit strategy that not only support biodiversity, but also improve human experience and contribute to climate resilience. Natural features sequester and store carbon, reduce stormwater runoff, help mitigate against urban heat islands, filter air pollutants, and much more. Given the links between biodiversity, human well-being, and climate resilience, we're drawing upon a science-based framework that we developed. This was published in a report last year called Making Nature City. It is available online on our website. And what we did was synthesize scientific literature and trying to identify the key drivers of urban biodiversity support. And came up with 7 elements. The first element is patch size, or the size of a contiguous vegetated space in a city. And what we found is that there's a threshold for these vegetated green spaces at 2 acres. Overall, larger patches can support more biodiversity, and we roughly classify them into patches, which are between 2 and 10 acres, local hubs that are at least 10 acres, and regional hubs which are larger than 130. The idea here is that what we found in research is that larger features have the ability to support a greater diversity of species, making these habitat areas less sensitive to edge effects and being able to support species that are more sensitive to human disturbance. The second element is connections. These are linear, either vegetated or water features that facilitate the movement of plants and wildlife through cities. Examples of connections are green streets, greenways, riparian corridors, and wildlife crossings. Third element is called matrix quality. These are little habitat elements, not large enough to be considered patches or connections, and can include features such as landscaped areas, residential yards, street trees, green roofs, and different forms of green infrastructure. An important point to make here is that matrix quality improvements arranged in relation to patches and corridors are most effective by increasing the connectivity between these features as well as their effective size and width. The fourth element is habitat diversity, or the type, number, and spatial distribution of habitat types within an urban area. Habitat diversity plays out at a variety of scales. So at the site scale, it's important to mimic the habitat structure and complexity, the layers of native habitat types. When you zoom out at the neighborhood scale, it's important to increase the coherence, trying to replicate the spatial extent that a habitat type such as an oak woodland would have had. And when you zoom out even more, making sure that there's a heterogeneity, so habitats that are adjacent to each other that can transition and support the different life cycle of a species. The next element, or the fifth, is native vegetation. So those are plant species that have long evolved in a specific geography. They have complex relationships with local wildlife, and therefore their presence increases biodiversity. They provide year-round resources. Complementary plants have evolved to have relationships with them and offer flowers, fruits, and nuts. The sixth element is special resources, or unique habitat features necessary to support species-like history requirements. These include streams, large trees, wetlands, and different kinds of water bodies, such as lakes and ponds. Last but not least, we have the seventh element, management. So human activities and planning that promote positive biodiversity outcomes, such as leaving leaf litter on the ground, using bird-friendly windows in buildings, or reducing the amount of chemical inputs in landscapes, reducing the amount of mowing and the extent of lawn cover. So how do these elements play out in Moffett Park? What you see here is an aerial image of Moffett Park. The white dotted line, shows the boundary of the specific plan that we are looking at today. And what has become really apparent is that Moffett Park is a pretty classic office park and light industrial area. So there's quite a bit of surface parking lots in general, impervious cover throughout the district. Moffett Park, however, is located along the Baylands, and therefore it is adjacent to a number of regional hubs for biodiversity, large patches that are at least 130 acres. Most important, that's located within the specific plan boundary is north in Lockheed Martin's property, where there are a number of stormwater detention basins that have led to the formation of wetlands. The rest of the district has a couple small privately held green spaces that are of relatively low ecological value. They're predominantly populated with ornamental vegetation and lawns. There are three main connections in Moffett Park today, namely the Lockheed Martin Channel, the West Channel, and the East Channel, which connect the urban landscape to the Baylands. These today are not the strongest connections, but have the potential to be improved upon, which I will talk about a little bit later on. In terms of matrix quality, we're analyzing existing conditions by looking at tree canopy cover, which is remarkably low at just 9%. This is also something that we would like to improve upon, hopefully reaching 40% in order to guarantee cooling benefits. In terms of habitat diversity, this map illustrates the historical ecology of the site. So before colonialization, there was this rich mosaic of habitat types, including tidal wetlands, salt flats to the north, as well as alkali meadows, wet meadows, and oak savannas. Native vegetation today is largely absent. What we see here is that most street trees and most of the vegetation that's found along the channels is non-native. However, there are a number of special resources, the channels that I mentioned, the wetlands that have formed on Lockheed Martin's property, as well as a number of large trees, predominantly along Caribbean Drive. Management is not something that we're able to map, so I will skip it in terms of looking at the existing conditions in the map. But I did want to take this opportunity also to talk about the urban heat island effect, or this phenomenon that's described as cities being 4 to 6 degrees hotter than rural areas. And what we see here, this is a snapshot of surface temperature recorded during the heat wave on Labor Day weekend back in 2017. You might remember that was a very hot day. And what we see is that Moffett Park is extremely susceptible to the formation of urban heat islands. Most of the district was at about 99 to 102 degrees, with some areas spiking, and generally surface temperature increasing as you move away from the baylands. One thing that's important to note here as well is that the highest surface temperature was actually recorded in the Twin Creeks facility at about 138 degrees. This is a reminder of some of the potential drawbacks from using synthetic turf. So that starts to paint the picture of like what is our starting point. But I'd like to also take this opportunity to talk about some of the main opportunities and ways that Moffett Park can transition into an ecological innovation district. First one is patches. There's quite a bit of underutilized land. Surface parking lots seem like low-hanging fruit in order to create new habitat patches within Moffett Park's landscape that can provide immersive nature experiences that have been associated with the restorative benefits and increased creativity and general well-being. Outside of these more ecologically oriented green spaces, we think there's overall an opportunity to improve the ecological value of all open spaces. So even more civic-oriented hardscape plazas can contribute to biodiversity support by integrating natural elements. Another big opportunity is increasing the accessibility of these green spaces. Even if they're in private land, these green spaces can be made publicly accessible to both potential residents of Moffett Park's district and neighboring communities. In terms of connection, there's an opportunity for there to be synergies between ecology, stormwater management, as well as innovations in mobility. So shaded streets and greenways can contribute to creating safe and comfortable mobility corridors, particularly on hot days. The channels themselves present this great opportunity to improve access to the shoreline. There can be upgrades to the vegetation, increases in building setbacks, and other improvements that can enhance the ecological value of these existing connections. In terms of matrix quality, as I was mentioning before, there's this opportunity to increase the overall tree canopy cover that can help contribute to climate change mitigation and adaptation, providing substantial cooling benefits, biodiversity support that increase the permeability of the landscape, as well as sequestering carbon and filtering air pollutants. Another easy way to increase the ecological value of the overall urban landscape would be to both replace non-native vegetation and make sure that we plant native vegetation in any new open space, and using that as well in stormwater detention features. Those are the three main points that we would like to highlight in terms of opportunity, but by no means that is an exhaustive list. There are many other things that we can explore later on. This might seem a little tangential, but I think COVID-19 is on all of our minds, and I'd like to take this opportunity to reflect in terms of like how COVID-19 can affect ecology or ecology strategies in Moffett Park. One thing that we found in this experience is that green spaces and corridors are more important than ever. Now that we're all practicing social distancing and limiting the amount of like recreational opportunities available, these open spaces can provide valuable opportunities for people to get outside. That, in addition to the abundant amount of emergent research showing the benefits, the health-related benefits of parks and other natural features that can improve mental and physical well-being, as well as help building social cohesion, build a case for the importance of expanding the amount of nature and parks available in our cities. With the right design approach, we can make sure that these open spaces can be flexibly designed to both accommodate the needs during this kind of crisis and pandemic, and more active programming uses in the future. I will stop there and hope that you will be able to answer our short survey at the end. Thank you very much.